So, shift registers, so these are special type of registers where instead of loading the value parallelly into the register, we load it in a serial fashion. So, here a number of flip flops have been connected in series, as you can see here. So, this Q output of this first flip flop is fed to the D input of the next flip flop. Similarly, Q output of the next the second flip flop goes to the Q input of the third flip flop, and that way we connect n such flip flops. So, in a parallel load register, these n values, the values into these n register n flip flops will be loaded parallelly. So, you need n parallel pins to be there in the chip, by which you can load feed that n bit pattern. But in many cases, what happens is having so many number of pins is difficult in a chip. So, in those situations, the serial register they come into use, like we have got a single input pin which is serial input. So, here whatever bit we give in the first clock pulse, so that bit gets latched onto the first flip flop, and whatever was there in the first flip flop gets transferred to the second flip flop in the chain, and so on. So, as a result, if there are n such flip flops connected in a chain like this, then to load a particular bit pattern, so you have to shift the patterns n times. Okay, the bits are to be fed serially n times, and in every clock one bit will be put into the register. So, the bit for the last flip flop should be loaded first, so that in the total shifting process that bit finally reaches the final flip flop. So, this way we have got serial in serial out type of shift register as it is shown here. So, we have got a serial out pin. So, output of the last flip flop is coming out as the serial output from the register. So, we also can have serial input parallel output type of shift register, where the input is coming serially, but output is available in a parallel fashion. So, this may be useful in some cases where we need the parallel output. For example, if we have loaded 2 bit patterns into 2 shift registers and just want to sum them up. So, we have got 2 shift registers like this. So, this is one shift register, this is another shift register, and then individually they may be 4 bit 4 bit. So, they are shift registers. So, they have got one serial input line. So, this is serial input 1 and this is serial input 2, serial input 2. So, they are coming. So, after the 4 bits have been loaded, so they may be given to an adder, a 4 bit adder, and that at that time these 4 bits are fed parallelly. So, these are 4 bit lines coming from the two flip flop 2 registers, and the result is also 4 bit. So, this type of cases, so we need serial input parallel output type of configuration. So, that is also used in some situation. Then we have got a parallel input serial output type of configuration. So, here the values are loaded parallelly. So, this load control, when this load is equal to 1, then this load signal comes here. As a result, this AND gate at the output here. So, you will get the value whatever value is given at pin 1D. So, that comes here, and since this is coming through this load shift and inverted. So, if load shift line equal to 1, so this will get a 0 here. As a result, this OR gate outputs finally this 1D value, and that gets loaded into the D flip flop. On the other hand, the second bit pattern that you have loaded parallel, given it here parallelly, that also gets loaded into the second flip flop. So, that way we have got the parallel in type of configuration. Now, it is a serial out, like if you want to shift out the value. So, you have to give the shift, you have to make this load shift line equal to 0. As a result, this output of this inverter will be equal to 1. So, whatever is coming as serial input, so that will be coming to the first D flip flop. So, this serial input bit comes to the first D flip flop. Output of the first D flip flop is coming as the input of the second D flip flop. So, now it behaves as a serial shift register, serial input serial output shift register. So, we have got this parallel input serial output type of shift register configuration. So, in this way we can have different types of shift register configuration. We can also have parallel in parallel out type of shift register. So, here you can have this parallel input like 1D, 2D up to ND. So, n possible data bits that you want to store into the register, and then we have got this load shift line. So, if load shift line is equal to 1, then the value from this 1D, 2D to ND. So, that will get loaded into these flip flops. On the other hand, if this load shift line is equal to 0, then whatever is coming in the serial input, so they will be loaded into the D flip flop. Also, I have got this parallel output available. So, this for getting the parallel output I do not need to do anything, because I just have to have this extra n number of pins in the chip where these Q outputs are available on those pins. So, we have got those n bits. So, this is basically a parallel input, it also has got a serial input, and then it is a parallel output shift register. So, it is parallel input stroke serial input and parallel output shift register. So, this way we can think about different types of shift register configurations, and they are used in different applications. So, the most generic structure of this shift register we can think about is the universal shift register. In universal shift register, so it should be able to serial, I should be able to choose between serial or parallel mode of inputs, serial or parallel mode of outputs. I should permit shift left or shift right. So, in this diagram, so if I say that these flip flops are drawn in a horizontal fashion. So, this is the leftmost flip flop, this is the rightmost flip flop. So, the shifting that I am doing here is from left to right, but it may be the other way also. We can connect this Q output to the previous D flip flops input. Similarly, finally, so this Q output to this D input, and the serial input line can be connected to the last D flip flop. So, as a result I can get a right shift type or left shift type of configuration. So, that actually gives us the thing like we can permit shift left or right, and we can also shift in new values from left or right. So, that is we should be able to put a new value into the register either from the left side or from the right side. So, an universal shift register should have so many controls. Okay. So, there should be parallel input output facility. So, these are the parallel lines, parallel input, and this is the parallel output. I should be able to have this left serial in and right serial in, then this left serial out, left out, and right serial out, right out, and the clock signal is definitely needed. There is a clear signal, so that if it is given, so it will clear all the flip flops. So, it will be the register content will become 0, and I need to select between these 4 modes. Okay. So, here you see that the register can operate in any of these 4 modes. So, I need to select between those 4 modes, and for that I need 2 mode bits S0 and S1. So, it may be like this, that if S0 S1 both are 0 0, nothing happens, the flip flop contents remain unchanged. So, this is the hold state for the register. If it is 0 1, then we are doing a shift right. Okay. If it is 1 0, then that control may translate into the shift left command for the shift register, and 1 1 it may be for loading new input. So, this way we can think about different types of control, different modes of operation for the shift register, and we have to set this S0 S1 pins accordingly to get the job done. So, you can extend the designs that we are doing here. Okay. So, so that it can take care of this S0 S1 controls you can introduce into this design and get the whole thing done. So, I am not showing that design explicitly because the design will become a bit complex, but this is nothing very difficult. So, you just have to draw the corresponding combinational logic that should feed the individual flip flops, and that will be giving us the full functionality. Rather, we will be looking into the applications of this shift register, like in which situation we can use the shift registers. So, there are several uses. Sometimes we can use it for counter design. So, these ring counters and Johnson counters. So, we will see them later. There are some application in pseudo-random binary sequences and encryption. So, pseudo-random binary sequence basically generates some random number. In many applications, so we need random number generators. So, when you are writing a program in software, so you know that there are normally the operating system provides you with the routines like a random number generator. But how those random number generators are working? So, it may be that you have got some random number generation algorithm that runs, but while you are doing in digital circuits, how can you have a random sequence? Okay, so, these shift registers, they can be used for generating some random sequence, and then once you have got these random sequence generators, so they can be used for data encryption type of application. So, there are also ready made shift registers that are available in integrated circuit such as 74165. So, they are shift registers are available as chips. So, you can use it directly. Another application is conversion of data from serial to parallel and vice versa. So, large scale devices such as universal asynchronous receiver transmitter or UART, so they are based on shift register. So, this universal asynchronous receiver transmitters or UART, so they come as separate chip or they come as part of some processors also. Like what happens is that if you want to transmit some data over from one system to another system. So, if you are using a parallel type of transfer, then there are large number of lines which has to run parallelly over maybe a long distance. But instead of that, if we have got less space and we are so we can use a single line, because serial, if I transmit the data serially, then the only one line is needed for doing that data bit transfer. So, that many times we need this serial transmission, and that is asynchronous in nature, because the two systems at the two ends that we have of that transmitting line, so they are operating at their own clocks. So, naturally that is an asynchronous system. So, this type of there are this type of system. So, we need this module which is known as UART. Okay. So, that essentially uses a the shift register. So, from the source, if this is the processor from where I am this is a source processor from where I am sending it. So, there is a special register here. Okay. So, for the data, the processor loads this register parallelly. Okay. The value is loaded here, but from here the data is transmitted serially. So, you need a parallel input serial output type of register. Similarly, at the receiving end, so you have got a similar type of register. So, where this serial line is connected and it outputs the parallel line. So, this is a serial input parallel input serial output type of combination that we need here, and at the receiving end we need a serial input parallel output type of combination. So, both the cases, so we need some shift register for doing the thing. Some functions available in microcontrollers or microprocessors where the shift on or rotate type of instructions. So, there also you need to shift the bits of a register by a number of places, and there also we will see that we will have to use this type of shift register. So, this will be more clear when we go to our discussion on microprocessors, particularly 8085 microprocessor. So, then it will be clear further. However, so, a basic shift register, from our understanding, you see that it is nothing but a chain of D flip flops with a common clock. So, a clock is going everywhere, and the serial input line is connected to the D, Q output of the first flip flop is connected to the D input of the next flip flop, and it goes like this. So, each flip flop, it transfers its D input to its Q output and at a clock transition. When when the clock signal makes a transition, so this from serial input it is transferred here. Similarly, from this Q it transferred to the next D. So, that way it goes. The effect is to transfer data along the register one flip flop per clock cycle. So, it is going one flip flop per clock, and this type of register is known as serial input serial output register, or SISO. This is one terminology which is quite often used, which is SISO register, serial input serial output register. So, timing behavior is like this. So, if this is the clock signal that we have got, and suppose we have got an input pattern like this. Okay. So, it was initially low, then it is high for some time, then it is again becomes low for some time, then again high for some time. Then this QA, that is the first flip flop, so it is fed directly from the serial input. So, at the clock transition, so it looks into the value, like here there is an edge. So, this value is sampled and the QA makes a transition accordingly. So, there is a delay associated with the flip flop. So, this is the delay that we have. So, after that QA becomes high. Then at the further time at further clock edge, further rising clock edge, this input is still 1. So, it remains high and it goes on like that. Okay. So, it goes on like that. So, similarly at the third clock, so it goes high and it when the third clock step it goes high. So, it is also having this input as high. So, this value is sampled here. So, this way it goes on, and finally, when it at this particular clock edge it finds that the input is low. So, the QA output becomes low and it now it becomes low and continues with the low value till the next clock edge where it is again low. So, this is sampled at that time. If you look into the second flip flop, the B flip flop, then at the first clock edge it finds that QA is 0. So, it remains 0. At the second clock edge it finds that QA is 1. So, it becomes high and it goes on like this. Similarly, QC it at previous clock edges. So, it finds that the QB is low. So, till this clock there is no change, but at this clock it finds that QB is high. So, it will be making a transition like this and it will continue like that. Now, this way so we have got this propagation delay TPD. So, this is from the clock edge after how much time the transition will occur. So, that is the TPD or the transition time. Okay. So, pattern in successive flip flop moves to the right with each clock cycle to shift the pattern into and out of the register. So, that happens in this shift register. So, you see how this 1 is getting transmitted. So, so it is shown here. So, this 1 is actually transmitted to this QD after 4 clock cycles, and that has to be taken into consideration, that after 4 clock cycle the value will come there. So, another some applications of this basic shift register are like this delay line. Like if you want to put an end stage delay, that is when a particular clock edge comes. So, you want that the circuit your actual circuit should get that signal after some time, after some n clock pulses. Okay. So, you put an end stage delay and then the signal will be coming here. For example, what I mean is, suppose this is my actual system and the signal comes from some other systems, so the signal comes here. But what you need is that when this signal is generated, after some delay the signal should be available here. So, what you do, in between you put some shift register of sufficient number of stages. Okay. So, you put a shift register of sufficient number of stages, so that this signal gets transmitted through this shift register and then finally it comes to this register. So, we can have this in this way this shift register behaves as a delay line in this particular case. Now, another application is multiplication and division by powers of 2. So, you see, suppose we are doing a multiplication by 3 by 4, that is 12. So, it becomes 3 is 1 1 and 4 is 1 0 0. So, it is 1 1 0 0 in the binary arithmetic. Now, you see this, when we are multiplying 3 by 4. So, it is nothing but we are doing a shifting of this 1 1 towards the left by 2 bits. So, this is the left shift operation. So, what I mean is if I take a 4 bit number and the 4 bit number representation, then this 3 is represented as 0 0 1 1. Now, when I am multiplying by 4, what I am doing is that I am shifting left by 2 bit position. So, left shift by 2 bits. So, if we do that, so it will become 1 1 0 0. So, that is essentially multiplication by 2. So, this multiplication by 2 powers of 2 is a very common operation in computer applications. So, there we can do that by shifting left by n bits. On the other hand, if you are doing a division, so division by powers of 2, then it is nothing but right shifting the content by appropriate number of bits. So, the sense of shift left or right, so it is based on its effect on binary numbers written in the usual way. For example, this 1 1 to 1 1 0 0. So, this is called a left shift, and this is numbers written in 8 bit format is like this, and then you are transmitted towards shifting towards left. So, this 2 ones get left shifted by 2 positions. So, it becomes 0 0 0 0 1 1 0 0. And similarly, when you are dividing by 2, so this is this factor becomes like this. So, this is a right shift operation. So, this is a left shift and right shift operation that we have got. Now, another application that we have of the shift register is known as pseudo-random number generator. So, this is a shift register, but only thing is that, so this Q output of the last flip flop, so it is connected back to the first flip flop via some XOR gate, and this XOR gate, it has got some of the bits tapped from this shift register stages and connected to it. For example, in this case the last two flip flop outputs, so they have been XORed and then fed to the first flip flop. So, this if you start this D flip flops, if you initialize these D flip flops with any value other than all 0, then what will happen? So, it will be based on these values in this these two flip flops, this shift value will be determined. Accordingly, it will generate a sequence. For example, we can if we say that we started with the pattern say 0 0 1 1, that is these two flip flops are 0 and these two flip flops are 1. Then what will happen? So, these two 1s, so they will be XORed here. So, you will get a 0 at this point. So, at the next clock, so this is a shift register otherwise. So, by the shift register operation, so these 3 bits will be 0 0 1 and this bit will become 0. Similarly, in the next clock, so this one will be going out. So, you will be getting 0 0 0. So, these 3 zeros will be right shifted by one position, and this 0 and 1 they will be XORed and coming as input to the first flip flop. So, it will become 1 0 0 0. So, at the next clock, so you will get this 1 0 0 here and then this 0 0 will be XORed and you will get a 0 at the first flip flop. So, this way it will go on generating a random sequence. So, first it is 3, then 1, then 8, then 4, it is generating a random sequence. So, the pseudo random sequences of 1s and 0s have many applications, particularly in the field of encryption. We will see they appear to be random over short time periods, and because the sequence will eventually repeat. What will happen is that in this way, if you trace out this sequence, then after generating all the 15 non-zero patterns, so it will again come back to this point. So, it will start generating from the beginning. So, that is the pseudo randoms, that is why it is called a pseudo random sequence, not a truly random sequence, because after some time the sequence repeats itself. So, it is a pseudo random sequence, and they can be reproduced perfectly if you know the following thing: the method used for generating the sequence, that is what is the structure of this shift register, that is, but in particular what is the from which points, from which flip flops you have taken inputs to be XORed to be fed back to the first flip flop. So, if you know that information and you know what is the initial pattern that you have fed, so given these two information, you can reproduce this sequence at any point of time. Okay. So, that is why we must the method used to generate the sequence, which is basically these XOR tapping points, and the state in the sequence at which it starts. So, that is the first value of the shift register. And this in this particular case, so after 15 cycles it will be repeating, and as I said that the state 0 will not come, because if you load 0, then it will always remain in the 0 value. So, it will not be having any other pattern here. So, it will always be at 0. So, it cannot generate the sequence 0. Apart from that, it will generate all other patterns. So, what do you do? So, this pseudo random sequence generated, so they have got application in encryption. Okay. So, in encryption what happens is that you have got some plain text which is combined with some key value, and accordingly it will generate some encrypted result. Okay. Like in this particular case, suppose this is your plain text is coming, which I am considering the plain text also as a bit sequence. So, it is coming here, and you have got a pseudo random binary sequence. So, that is generating the pseudo random pattern. So, the successive bits that are generating, so you do an XORing of them, and then you see what is the output coming. Since it is XORed, so naturally the nature of this plain text will be lost, and you will see something like binary noise. Okay. So, which will appear to be apparently normal. So, at the sender end we do it like this: we XOR this plain text with this pseudo random binary sequence generated by the shift register, and then we just after doing the XOR we start transmitting over this channel. So, at the receiving end what you do, you use the same pseudorandom binary sequence. So, you are using a shift register where these feedback points are same, okay, to the first XOR gate. So, this the same structure is used here, and also you start at the same initial pattern. So, once you start at the same initial pattern, then the same sequence of random numbers will be generated here, and that you can XOR with your plain text. So, so since this, if it is say, if your plain text is say A and this if your plain text is say A and this is B. So, at this point I am getting A XOR B. Now, what is happening is that, so here I am using the same pseudorandom sequence generator starting with the same initial pattern. So, this is basically B. So, at this point, so this is A XOR B, and at this point I get A XOR B XOR B. So, this B XOR B is equal to 0. So, I am getting back A. So, whatever A you are transmitting, so you are getting here, but in between in this, while it is getting transmitted through this channel, so this is encrypted as A XOR B. So, this is the property, that if you exclusive OR a bit with the same value 0 or 1 or twice, you will get the initial value back. So, that is the property of XOR. So, that is used for this encryption algorithm. So, this pseudorandom sequence generator, it has got application in this encryption algorithms.